Okay. So now good morning class. So now we're looking at worksheet 10D. The question says, in number 1, prove that triangle. So we are required to prove that triangle ABC is congruent to triangle EDC. So to start with congruency or similarity, we say in triangle ABC, the odd and triangle EDC. Here the order doesn't matter, but most of the time if the order, or you can almost say all the time that if the order is given, then that is the right order that the triangle need to be in. Why is the order important? Because in conclusion, when you say that the two triangles are congruent, that means to say all the corresponding angles, which in this means to say that A is equal to E, angle B is equal to D, and angle C is equal to angle C. Corresponding angles are all the corresponding sides, which means to say AB is equal to ED, BC is equal to DC, and AC equals EC. That's why the order is important, okay? Because like all the corresponding angles and all the corresponding sides are, of course, equal, okay? That is why order is important. So let's go with it. To prove congruence is one of 3. Okay, just right here is either going to be side, 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 angle, side, angle, angle, side, and the RHS right and hypotenuse side. If we use side, angle, side, it must be an included angle, which means to say if you know those two sides, it must be that angle. If we don't have that angle and we have any other angle, it's not enough information to conclude congruency. Again, with the RHS, many learners get confused here. It's not every 90 degrees is RHS. If we have 90 degrees, we got that side and we have known that side. But then, of course, the other triangle as well. That is going to be an example of side, angle, side. For RHS, you must have the 90 degrees and you must know the hypotenuse. Okay? And of course, the 90 degrees opposite the hypotenuse. Alright, so let's do this. It's a very important skill to know this. We'll use it extensively in grade 12 as well. So, we say in a triangle ABC and triangle EDC. What can we say about the two triangles? We know that AC is equal to CE. Why is that equal? Because that's given to us. Then we know that BC is equal to CD. Why? That's also given to us. It's given on the diagram. Then we know that angle C1 is equal to C2. Why? It's vertically opposite. Okay, so what do we get? There's enough information to conclude congruency. So therefore, triangle ACB is congruent to triangle. So in ACB, so I must then say ECD. And what's the case here of the 4? Side, angle, side. Okay. Actually, I had to go with the what's the name? The reason, the order there. So in future we'll just pick up on the order. Okay, sorry about that. Okay, number 2, I've drawn wrong, so I had to redraw. People, this video is free. Okay. If I have made any mistake, you have a better solution, you can let me know on that number. Otherwise, as I said, it is completely free. Okay. So, we are given in number 2. Number 2, they ask you to prove that triangle ABC is congruent to triangle RPQ. So we start off by saying in the triangle, and we give the order as they give it. Is triangle ABC and triangle. We don't say congruent at this point, okay? Because why? We need to prove it. Alright. To make it a bit smoother, as I say. So, firstly, if you see that they're given in the same angle, of course the angles are equal. So here I can just say angle B is equal to angle. Now we can't just say angle P, because there's 1, 2, 3 angles at P. So now I have to say QPR. Okay? And the reason here is given. As you can see, both has the spade in it, okay? The U doesn't look like a spade, right? I tried at least. So then AB, as we know, AB is equal to PR. Why? That's also given to us. Now you see these lines are parallel, so it's either we must find another side that's equal, we don't know those sides are equal, or we must find another angle that's equal. So here's parallel lines, here's 90. So if you look at the alternate angles here, there's also 90, not so. If that's 90, then C2 is 90. Why? Because the angle's in a straight line. Then we can conclude that C2, of course, is equal to angle Q. Okay? So there's the first case, the second, the third is that we firstly say that angle Q, as you can see, it's only one angle, this I can say angle Q, that is C1 is equal to angle C1. Why? Because of alternate angles, name the angles and lines that's parallel, so AC is parallel to QR. Okay. Then we're going to say that C2 is also 90 degrees. Why? Because the angle's in a straight line. So therefore, Q1, angle Q is equal to C2, which is equal to 90. So there's a third case. Can you see that? Not the third case, but the third point we can say. So in conclusion, we can say, here we see 90 degrees and the hypotenuse. So this is an example of RHS. Okay? So we can conclude that, therefore, triangle ABC, we're going with the order, is congruent with triangle RPQ. So A, yes, R, P, yes, that's the correct order. So RH is right hand hypotenuse side is of course the case for congruency number 2. Let's go with number 3. Okay, I know my diagram is lopsided, it's not drawn accurately. Right, so the question says you are required to prove that ABC is congruent to triangle ADC. Right, the order is also in order here. In triangle ABC and triangle ADC. So what do we say? When you found the two triangles, AC is a common side. Don't just say common, because later on we'll have common angles as well. So say that I think it's a common side. BC is equal to DC. That is equal. How is it equal? It was given to us. Given equal. Then you see that angle B and angle D is both 90. So angle B is equal to angle D, which is equal to 90. Why? It was also given to us. So this is enough information to conclude congruency. As you can see, there's 3. We use the 90 degrees and there's hypotenuse. So again, a case of RHS. So therefore, triangle ABC is congruent to triangle ADC. And the reason is RHS. Okay. Let's pause here, draw the next diagram. Okay, in number 4. This is also a very, very good example of a lopsided figure, or a diagram not drawn to scale. Okay, I've tried, but I put it in line, but okay, I messed it up in the long run. But anyway, as you can see here, those angles are given equal there. The question is, you're required to prove that angle A is equal to angle C. Okay, I'm not going to waste paper and redraw, but as I said, this diagram is not necessarily the best of diagrams here. So, to prove that angle A is equal to angle C, there's no link there, as we can go with working out angle and so on. However, if we prove that this triangle is congruent to that triangle, then the corresponding angles will be equal. So let's prove congruence here. So we say in triangle ABD and triangle, so it's ABD, so CBD. So what can we say at this point? Okay, I'm going to start the next video.